So this is 4 key notes, and the learning target is simplify and perform operations on complex numbers. Start off with complex numbers. The first thing is an imaginary number, and the imaginary number is defined as the square root of -1. And we represent this with the letter I. So anytime you see an I now in math, that represents the square root of -1. So now, first thing you're going to have to do is simplify the square root of a negative number. So we're going to break this down into -49 can be broken down into +49 times -1. And let's break this up further. Square root of 49 times the square root of -1. Well, the square root of 49 is 7, and the square root of -1 is I. So our square root of -49 simplifies to 7i. Next example, we have square root of -72. Simplify this. So we have 72 can break down into and -1. So square root of 72 times the square root of -1. -1, we know that is I now, but the square root of 72 is not a perfect square. So you can break this down with trace if you like. All the prime numbers, I circle them to look at those further. That's a square root, so I'm looking for pairs, a pair of 3s and a pair of 2s. So let's look at this further. So 3 comes out, a 2 comes out from the pairs, and -1 here, square root of -1 comes out as an I. And what's left underneath the square root is the 2. So simplifying this further, 3 times 2 is 6, I square root of 2. So square root of -72 is equivalent to 6i square root of 2 in simplified form. Next one. So I'm actually going to skip that example and move on. A complex number now is a number in the form, it's going to be a plus or minus bi. It could be a plus, it could be a subtraction. A and b, so a and b are going to be real numbers. Real numbers are all the numbers you've always talked about up till today. So this could be, an example is, if a was 3 and we plus 2i. That's a complex number. There's a real portion to it and an imaginary portion to the number. So together it's a complex number. It could be like -5 minus 2i, or -1 plus 6i. So real numbers could be 0.5 minus just I. The b is 1. So these are called complex numbers. So with adding and subtracting complex numbers, it's very, very similar. Just treat it like it's variables. So treat these problems like you do with variables with adding and subtracting. So get your like terms together. So we're adding here. So add 3 plus 4 is 7. Positive 7i plus negative 6i is a positive 1i. And that would be your final answer. With a subtraction here, you have to look at, so it's again, get your like terms together. So 6, you're subtracting 10. 6 subtract 10 is -4. Then we look at, we have positive 3i and we're subtracting -4i. Subtracting -4, so that's like 3i subtract -4i. That's the same thing as 3i plus 4i, which is 7i. So down here it's going to be positive 7i. There's another way you can do this that kind of, because the subtraction can get kind of confusing. So another way that I've seen people do this problem is actually distribute this negative in. So if I'm going to rewrite the problem, it'd be 6 plus 3i. And then since I distributed that negative in, you actually don't need parentheses. So it'd just be 6 plus 3i, and then be minus 10 plus 4i. So I distribute the negative in like it's negative 1, and then gather like terms. Negative 4 and 7i. So that's another way you can do the problem. Distribute in the negative first, and then gather like terms. Next is multiplying. So with multiplying, again, you treat it very, very similar to variables. We have a binomial times a binomial, so some of you notice FOIL is really double distribution, it's called, so we're distributing the 2. So 2 times 4 is 8, and then 2 times 5i is 10i, so it's just like the variable. Negative 3i times 4 is negative 12i. Negative 3i times 5i is a negative 15i squared. So when we're simplifying this, we have 8 plus, no, not plus, 8 minus 2i, these are like terms. But now that we have an I squared, I didn't talk about this before, but remember that I is equivalent to square root of negative 1. What happens if I square I? What would happen to this? So if I square I, do it on this problem here. If I square it on both sides to keep the equation balanced, I squared would equal, these cancel out, just equals negative 1. So this I squared here that I see, that's going to be equivalent to negative 1. So it'll be negative 15 times negative 1. So negative 15 times negative 1 is positive 15. Now we see we have like terms again. So that 8 plus 15 is 23 minus 2i. So moving on, multiplying again, just the one binomial or monomial times the binomial. So negative 12i and minus 42i squared. Again, you see we have an I squared. Anytime you see an I squared, think of that as negative 1. So I'm going to replace this with negative 1. So it'll be negative 12i, negative 42 times negative 1 is positive 42. And you should always write the real number first. So positive 42 minus 12i. Moving on to division. So division, I'm going to rewrite it. I don't like this division sign symbol. I'm going to write it as a fraction here. So it's 1 plus 4i over 5 minus 12i. To simplify this, we need to get rid of the I in the denominator. You cannot have an imaginary number in the denominator. To do this, you are going to multiply this by a fraction. So this is the fraction here. You're going to multiply it by a fraction, but you change the sign of the complex number. Change, or the imaginary. So change the imaginary sign. So you're doing 5 plus 12i over 5 plus 12i. When you multiply this out, you're going to multiply this binomial times a binomial. So 1 times 5, 5. 1 times 12i, 12i. 4i times 5 is 20i. And 4i times 12i is 48i squared. Let's see if I can make this bigger. So we have 5 minus 12i times 5 plus 12i. So multiplying out the denominator now. 5 times 5 is 25. 5 times 12i is 60i. Negative 12i times 5 is negative 60i. That's good, that cancels out. And the denominator, that's a negative 144i squared. Okay, so now let's concentrate on simplifying the numerators and the denominators. So, looking at the numerators and denominators, we have the numerator, we have 5, and let's see, we have a negative, or I squared, which is a negative 1. So that's 48 times negative 1. So we have 5. I'm going to combine these two here. 5, 48 times negative 1 is negative 48. So 5 minus 48 is a negative 43. And then, like terms here, the 12i plus 20i is 32i. And then over the denominator, we have the I squared again, so that's negative 1. Negative 144 times negative 1 is positive 144. So 25 plus 144 is 169. And middle terms here, those cancel out. And so that's 69 becomes your denominator. And now you look to see if there's negative 43, 32, and 169, if there's a number that's in common that you can simplify this with. And there's not a number to simplify this fraction. So that's just your answer. Okay, if you understood the last problem, you don't have to copy this one down, but if you didn't understand it, I'm going to go through another problem for you. So here's the division again. I'm going to rewrite this as a fraction. So 3 minus I over negative 4 minus 12i. Now when we multiply, we're going to multiply by, and it's always off of the denominator, and it's always the imaginary part of the complex number of the denominator. So you always change the sign. So it's negative 4 plus 12i. By changing the sign, it gets rid of the i's in the denominator, which is what your goal here is to do. So we have 3 minus I times negative 4 plus 12i. So multiply it out. Negative 12. 3 times 12i, 36i. Negative I times negative 4 is positive 4i. And negative I times positive 12i is a negative 12i squared. In the denominator, again, we have two binomials. Multiply them out. Negative 4 times negative 4 is 16. Negative 4 times 12i is negative 48i. Negative 12i times negative 4 is positive 48i. You see the middle term should always cancel with this, of the denominator. And negative 12 times 12i is negative 144. It's weird that they're the same as the other one. So now let's look at simplifying the numerator. So we have I squared, think of that as negative 1, so we have negative 12 times negative 1, which is a positive 12. We're going to add that to negative 12. That just becomes 0. So this here, negative 12 times negative 1 is positive 12. Add it to negative 12, and that's going to cancel out. They're going to cancel out. So we don't have that anymore. We have 36i plus 4i is 40i. So that's all the numerator is. The denominator, we have I squared, so that's negative 1. We have negative 144 times negative 1, which is positive 144. We're going to add that to 16, which puts us at 160. And then the middle two terms, they're opposites, negative 48i plus 48i, cancel out. So we're left with 40i over 160. Looking at the coefficients, 40 over 160, we can reduce that. Divide them both by 40 to get 1 over 4. 1 times I is just I over 4. Come to class with any questions you have. I'm going to do a notes check. I'm not going to have a warm-up, so be ready to answer any questions about the notes. Yeah, hopefully this helped you.